Hey, we have here another integral today. This one's from the Scranton Integration Bee 2019. This was problem from the finals, problem 19. We have the integral of the square root of x plus x squared times square root of x dx. Okay, I was really liking the look of this. It looks pretty complicated with the embedded square root and all these x's and stuff, so it's a little difficult to deal with in this form, so I think what we need to do is some algebra manipulation. What I thought I could do is just factor an x out of this. So if I rewrite this, if I factor an x out, we're going to have 1 plus x squared of x. And what that's going to allow me to do when I rewrite my integral, I can pull this x outside of the radical as a square root of x, and then we'll just have this part left inside this big radical. So we're going to have 1 plus, but this x squared of x, what I'll do is I'll multiply those together. X to the 1 times x to the 1/2 is going to be x to the 3/2 dx. And then from here, what I'm going to do is a u substitution on, we'll call that piece our u to simplify this radical. So let's see, we'll say u equals 1 plus x to the 3/2. Then let's take a derivative. So for our du, derivative 1, 0, derivative here is going to be 3/2 x to the 1/2 dx. And we also could write this as 3/2 square root of x dx. Well, in order to set up my du, I have the square root of x, I have my dx, all I need here is a 3/2. But I don't want to change this thing, so I'll multiply by a 2/3 out front, so we're just multiplying by 1. And then we'll make this substitution now. Okay, again, all this is going to be our du, but we need to deal with this radical. So 1 plus x 3/2, this is going to be u. So we're going to have square root of u, just going to write it as u to the 1/2 du. Then we'll just integrate using the power rule. So here, integral of u 1/2 is going to be u 3/2, bring a 2/3 in front. Multiplying this, we're going to have 4/9. And then I think I'm going to back substitute my u. We've got our u value right here, so we're going to have 1 plus x to the 3/2, all to the 3/2 plus c, and that's it. But alternately, if I wanted to look more like the original problem, let's see, I could do 4/9. We could do a square root, and then we could have 1 plus, we could write this as x square root of x, write it cubed, and then so we have, with the 3 and the square root, we have our 3/2 plus c, and that's fine as well. Okay, that's it. So we'll stop it there. Pretty good problem today. Thanks everyone for watching. Have a great day.